So good afternoon, everyone. So in the yesterday's class, I said that we are done with the entire syllabus, including the LAQs, SAQs, and VSAQs. So today we are going to see some important questions from all these topics. So as you can see, the screen, you are able to see the 7 LAQs. 7 LAQs. So from these 7 LAQs, around 99.9% will be able to get 3 LAQs, and you are supposed to write how many LAQs? 2 LAQs out of this. So initially I have started with current electricity and I have finished these 2 LAQs. Then I have finished this LAQs from nuclear physics. Later on, I have dealt with what? 5th, 6th, and 7th LAQ, that is the LAQs from waves chapter. So see here, these are the next important concept, that is SAQs. In SAQs, we have already discussed regarding electric charges and field, electric potential and capacitance, and wave optics. Further, we have did the numericals from electric potential and capacitance. See here, we are done with this electromagnetic induction, atoms, semiconductor devices, ray optics, and moving charges and magnetism. Further, I have finished very short answer type questions. And if I remember, we were discussing regarding important problems for long answer type questions. Important problem for what? Long answer type questions. So I think we have started nuclear physics, and in nuclear physics we have discussed around 5 to 6 numericals. Later on we have discussed one numerical from current electricity. I think one numerical from current electricity. Here, let us discuss the second numerical from current electricity. Second numerical from current electricity. The second numerical is a battery of EMF. A battery of EMF 10 volt and internal resistance of 3 ohms is connected to a resistor. Full stop. If the current in circuit is, if the current in circuit is 0.5 amperes, what is the resistance of resistor? What is the resistance of resistor? See here. So what we are having here, he said that there is a battery whose EMF is how much? EMF of the battery is given, that is E is equals to 10 volts. Next, what he has given? He has given that there is some internal resistance. What is the value of internal resistance given? That is 3 ohms. The value of internal resistance is how much? 3 ohms. And it is telling that it is connected to a resistor of resistance R. So we are supposed to determine that resistance R value. Next, what is telling? How much amount of current is flowing through the circuit? The current flowing through the circuit is I is equals to 0.5 amperes. 0.5 amperes. So see here, what will be the formula for this? We know that the formula is given as I is equals to E divided by R plus R. This is the formula. I hope you remember this. Here, terminal potential difference will come into the play. I is equals to what? E divided by R plus R. Which value we are supposed to determine? We are supposed to determine the value of capital R. So let us substitute the values. What we'll be getting? What is the value of current? It is 0.5 amperes. That is equals to how much EMF is given here? 10 volts divided by. You are supposed to determine the value of capital R plus what is the value of small r? It is 3 ohms. So if I cross multiply this, what this will become? This will become 0.5 into R plus 3 is equals to how much? 10. That is nothing but R plus 3 is equals to this 1 by 5 can be written as what? Otherwise, I'll write here 10 divided by 0.5. So what this will become? 10 divided by this 0.5 can be written as what? 1 by 2, isn't it? This can be written as 1 by 2. So this 2 will go to numerator. So how much it will become? It will become 20. So I can directly write the answer here. R is equals to 20 minus 3. That will be R is equals to how many ohms? It is 17 ohms. So this is the question given. So what he is asking? He is telling that there is a battery of EMF 10 volts. And what is the internal resistance of that battery? The internal resistance of the battery is 3 ohms. And it is connected to some resistor. Let me write this resistor R. Full stop. If the current in the circuit is how much? 0.5 amperes. What is the resistance of the resistor? What is the resistance of the resistor? So this is the final answer. Let us move on to the next question. So this is my next question. What is that second question? A battery of EMF, a battery of EMF 2.5 volts and 2.5 volts and internal resistance R, internal resistance R is connected in series, is connected in series with a resistor of, with a resistor of 45 ohms. 45 ohms through an ammeter, through an ammeter of resistance 1 ohm. Through an ammeter of resistance how many ohm? 1 ohm. Full stop. The ammeter reads a current of 50 milliamperes. What is that? An ammeter reads a current of how many milliamperes? 50 milliamperes. Calculate the value of internal resistance. Calculate the value of what? Internal resistance. So see here. Let us first of all draw the diagram for this. The circuit diagram will become something like this. Here assume that there is a battery. This positive potential, this is negative potential. And what is the EMF of this battery? It is 2.5 volts. And here we know that inside a battery, there will be one internal resistance. I am representing that internal resistance with R. I am representing that internal resistance with what? I am representing it with R. Next, it is connected to an external resistance. It is connected to an external resistance. How much external resistance? 45 ohms. It is connected to an external resistance of how much? 45 ohms. And further, he is telling that there is an ammeter connected in a circuit. We know that ammeter is always connected in a series to the circuit. And what is the resistance of ammeter? Resistance of ammeter given is how much? 1 ohm. 1 ohm. And the current flowing is also given. The current flowing through this ammeter is how much? 50. Where is that? 50 milliamperes. 50 milliamperes. So this is the entire complete diagram, the complete circuit diagram for this particular question. So what are the quantities that he has given? He has given the EMF of the battery, internal resistance. He has given the external resistance. Further, he is telling that the current I is equals to 50 milliampere is flowing. So what will be the formula? So the formula will become I is equals to EMF E divided by internal resistance small r plus external resistance capital R and resistance of ammeter. Let us write this one as what? Resistance of ammeter. So what is the value of current? We are getting the value of current how much? 50 milliampere. So how much? 50 into 10 power minus 3 ampere. That is equals to EMF is how much? He has given the EMF as 2.5 volts. So what is the value of small r that we are supposed to determine? And what is the value of capital R? It is 45. And what is the value of resistance of an ammeter? It is 1. So if I cross multiply this, what this will become? This will become R plus 45 plus 1 will become how much? 46 is equals to 2.5 divided by 50 into 10 power minus 3. 2.5 divided by 50 into 10 power minus 3. So what this will become? So this will become something like this. See here, 2.5 can be written as 5 by 2, isn't it? 2.5 can be written as 5 by 2. So this will become 5 by 2 into 50 into 10 power minus 3. If I take this 10 power minus 3 to numerator, what it will become? It will become 10 power plus 3. So 5 ones and 5 tens. 5 ones and 5 tens. So this will become how much? 1 by 2 in, we can cancel here itself. Why to write this entire thing? We can cancel here itself. So 10 ones and this will become square. So this will become how much? 10 square will become 100. 100 divided by 2. This will become how much? 2 ones and 2 50s. So from here I can write. What is that? This, it is the value of R plus 46. So what will R become? R will become 50 minus 46. So our final answer will become how much? Our final answer will become 4 ohms. Our final answer will become how many ohms? Our final answer will become 4 ohms. So this was the next important question for the LAQ. From which chapter? Current electricity chapter. So let us see one more question. What is that? Next important question from this chapter is a 10 ohm thick wire, a 10 ohm thick wire is stretched so that its length becomes 3 times assuming that there is no change in its density. No change in its density on stretching. On what? On doing stretching. Full stop. Calculate the resistance of stretched wire. So don't confuse this question with general resistance question. For general resistance question, what is the formula we'll be writing? We'll be writing the formula as what? R is equals to rho L by A. What is the formula we'll be writing? For general resistance, we'll be writing the formula as what? R is equals to rho L divided by A. But he is telling that here the density is remaining constant. On stretching, what is happening? Density is remaining constant. So in order to make the density constant, what is changing here? Its length is changing. So what I will be doing? I'll be multiplying and dividing by length. So what this will become? Rho L by A into L divided by L. So what this will become? Rho is equals, R is equals to rho into L square by area into length will become density. Area into length will become what? It will become density. So here density is remaining constant and rho is nothing but resistivity. It also remains constant. So what is changing with resistance? Length is changing with resistance. So I can write the formula here as R is directly proportional to L square. So I can finally write R1 by R2 is equals to L1 by L2 whole square. R1 by R2 is equals to how much? L1 by L2 whole square. So I am supposed to find the next resistance. So from here I can write resistance R2 is equals to L2 by L1 whole square into R1. So what is the, how much time the resistance has increased? The resistance has increased by 3 times. So this will become 3L1 by L1 whole square into R1. This L1 and this L1 will get cancelled. 3 square will become how much? 9R1. So our final answer will become how much? 9R1. So what is the resistance of the wire given? The resistance of wire given is 10 ohms. So how much this will become? 9 into 10 ohms is equals to 90 ohms. How much? 90 ohms. So this was the next important question from which chapter? Current electricity, LAQ chapter. Current electricity, LAQ chapter. So we are done with the problems from moving charges and magnetism. We are done with the problems of nuclei. We are done with the problems regarding capacitors. So let us move on to the problems from waves. Some important problems from wave, that is open pipe, regarding open pipe and closed pipe. Wave. Here, the first important numerical from wave will be a closed organ pipe. A closed organ pipe 70 centimeter long, 70 centimeter long is sounded, full stop, if velocity of sound is, if velocity of sound is 331 meter per second, what is the fundamental frequency of vibration? What is the fundamental frequency of vibration? So he is talking about which pipe? He is talking regarding closed organ pipe. So let us write down the given quantities here. Let us see what are the given quantities. Here he has given the length of the pipe. Length of the pipe is given how much? 70 centimeter. Next, what he has given? He has given velocity of sound. Velocity of sound, how much he has given? 331 meter per second. And is asking you to determine the fundamental frequency of vibration. In case of which pipe? In case of closed pipe. In case of closed pipe. So what this will become? This will become formula for closed pipe is how much? V by 4L. We have did the LAQ. We have did the LAQ for this particular topic. So F is equals to V by 4L. Let us substitute the values. What is the value of V here given? 331 divided by 4 into how much length is there? Length is in centimeter. If I convert this in meter, how much it will become? 70 into 10 power minus 2 meter. So this will become 70 into 10 power minus 2. So if you solve this, you will be getting the answer as, how much answer you will be getting? 331 divided by 4 into 70. So it will be around 118.2 hertz. Hertz is the unit for frequency. So in the examination, what you are supposed to do is, that if you are able to remember the formula and answer, then also you will be getting the 2 marks, because for LAQs, for a problem with LAQ, what you are supposed to write? You are supposed to write down the formula. For writing the formula, you will be getting the 1 mark, and for writing the answer, you will be getting 1 mark. So I hope you understood this question. Let us move on to the next important question from this chapter, which may be asked in LAQ. The second question from this chapter is, an open organ pipe 85 centimeter long, is sounded. Full stop. If the velocity of sound is, 340 meter per second, if the velocity of sound is 340 meter per second, what is the fundamental frequency? What is the fundamental frequency of vibration of air column? This is the next important question for LAQ. This question was also asked in recent examination. So let us see what is the answer for this. The answer for this will become, which type of pipe he has given? He has given open organ pipe. And what is the length he has given? Length L is equals to 85 centimeter. 85 centimeter means how much? 85 into 10 power minus 2 meter. And what is the velocity of sound given? Velocity of sound given is how much? 340 meter per second. And what he is asking you to determine? He is asking you to determine the fundamental frequency of which organ pipe? Open organ pipe. So what this will become? This will become V divided by 2L. For closed organ pipe, what will be getting? We'll be getting V by 4L. For open organ pipe, what we'll be getting? We'll be getting V by 2L. So what this will become? What is the value of velocity of sound? It is 340 meter per second divided by 2 into what is the length of the organ pipe? The length of the organ pipe is 85 into 10 power minus 2. So if you solve this, what you will be getting? You will be getting here 200, because 85 fourth the 340 and 2 the. So this 10 power minus 2 will go to numerator. It will become 200. Or I will write 85 once. Sorry. 85 ones, 85 fours. So what this will become? 4 into 10 power minus 2. If it go to numerator, it will become how much? 10 square divided by how much? 2. So 2 ones and 2 2s. So this will become how much? 200 hertz. How much? 200 hertz. So this was the next important questions. Next important question from this waves chapter LAQ, which you may expect in your annual examination. There is one more question, but that is regarding the steel pipe. But let us finish here itself. Please do practice the numericals from waves, nuclear physics, whatever 5 numericals that I have discussed in previous class. Then later on, discuss solve the numericals from current electricity, whatever I have discussed till now. And do these 2 problems for open pipe and closed pipe. It would be more than sufficient, I think, for the annual examination. There are problems regarding Doppler effect also, but I suggest you to finish or complete this, be perfect with nuclei and current electricity. Later on, move on to waves chapter. There is one more question which was asked in previous examination from waves chapter. Let us see that question. Hard question. The question given is a steel wire of 0.72 meter long has a mass of 5 into 10 power minus 3 kg. Has a mass of 5 into 10 power minus 3 kg. Full stop. If the wire is under tension, under a tension of 60 Newton, full stop. What is the speed of transverse wave on wire? What is the speed of transverse wave on wire? So see here. What are the given things? The given length is L is equals to 0.72 meter, and the mass of wire is how much? It is 5 into 10 power minus 3 kg. Further, what he has given, if the wire is under tension is how much? 60 Newton. He is asking you to determine the velocity of waves in a wire. So what is the formula for velocity of wave in a wire? We know that the formula is given as V is equals to under root T divided by mu, where mu is called as linear mass density. What is that mu? Mu is called as linear mass density. And what is the formula for linear mass density? Mu is defined as mass per unit length. It is defined as what? Mass per unit length. So what this will become? Under root T into mass per unit length, this L will go to what? Numerator. So if I substitute this value, what is the answer I will be getting? V is equals to under root T. What is the value of tension? Tension is 60 Newtons into what is the length of the wire? Length of the wire is 0.72 meter divided by what is the mass? Mass given is 5 into 10 power minus 3. 5 into 10 power minus 3. if I take this 10 to numerator, what this will become? This will become 60 into this 10 power 3. If I take to numerator, it will become 10 cube. So 10 cube into 0.72 will become how much? 720 divided by 5 divided by 5. So we know that what I can write, I can divide 60 by 5 also. If I divide 60 by 5, how much I will be getting? 60 divided by 5. It will be around 12, I think. So this will be 12. So this will become under root 12 into 720. If you multiply 720 into 12, so 2 zeros, 4, 1, 4, 0, 2, 7, 8640. I will be getting something 8640. So we know that what is the value of 9 square? 9 into 9 will become 81. So definitely this value should be greater than 90 only, because 9 square will become 81. So what will be 90 square? 90 into 90 will become 8100. So this value is greater than 8100. So its approximate answer, if you solve this, you will be getting the answer as around 92.9 meter per second, approximately 92.9 meter per second. 92.9 meter per second. Yeah, 92.9 meter per second. So this is the end for this answer. So most probably I have discussed the entire things, whatever things which are necessary for your examination, main examination, including LAQs, SAQs and VSAQs. And we are left with 2 more days to finish these things. So tomorrow, most probably, I will be checking whether if any questions are left which are not that much important, but maybe asked in the examination. We'll be seeing if any question is there, something like that. Otherwise, tomorrow I will show you the important questions and question paper, previous past 5 years question papers, so that you will get some confidence while writing the examination and even while revising for physics, SAQs, LAQs and numericals. So I hope whatever I have discussed, you have understood till now. So let me check if any questions are left so that we can teach you. We are done with numericals. We are done with semiconductors. We are done. Here, one question from electromagnetic induction is there. Not that much important, but sometimes he may ask. The question is from electromagnetic induction. Electromagnetic induction. The question is, obtain the expression for magnetic energy stored in solenoid. So very small answer which is important for 4 marks. I think only once he has asked this question. That is the reason I am discussing here. So see here, energy stored in a magnetic field is given as what? I know that energy stored in a magnetic field is given as UB is equals to 1 by 2 L into I square. Well, L represents self-inductance and I represents the current. And for magnetic solenoid, magnetic field due to solenoid is given as what? B is equals to mu naught N into I. B is equals to what? Mu naught N into I. From here, I can determine the value of I as I is equals to B divided by mu naught into N. Further, I also know that self-inductance for a solenoid is given as L is equals to, you are supposed to remember this, mu naught n square A into L. What is the value of L? Mu naught n square A into L. And what is the value of I? You are getting B divided by mu naught I. This you are supposed to remember. Now, if I substitute that value, what I will be getting? 1 by 2 into what is the value of L? Mu naught n square A into L. And what will be the value of I square? This will become B square divided by mu naught square into n square. This n square and this n square will get cancelled. Further, what are the things that are getting cancelled? This mu naught and square will get cancelled. So I will be left with what? I will be left with UB is equals to 1 by 2 mu naught, 1 by 2 mu naught B square into AL. So this is my final expression for magnetic energy stored in a solenoid. Magnetic energy stored in a solenoid. So let us finish today's class here itself. We are done with almost all types of numericals, SAQs, LAQs, VSAQs, extra SAQs we have already did. So in tomorrow's class, we'll be discussing only question papers. I will be showing you previous year question papers, or otherwise, if any other questions are left, I will be discussing that question paper. So let us meet tomorrow. I am going to finish the class here itself, as there are no content left for discussing regarding your annual examination. So thank you. We'll meet tomorrow.